Titrations aren't anything special. Titrations are just another reacting moles calculation they can ask you, but one that just involves two solutions. And because it's two solutions reacting, if anything, it makes it a little bit easier. Because rather than having to think about how can I work out the moles, do I need to do mass over molar mass, do I need to calculate MRs? No, because you're dealing with solutions, you only really have to think about concentration and volume to work out the number of moles, and number of moles equals concentration times volume. And if I were you, as soon as you realise a question is a titration question, just write that down at the top. So just do number of moles equals concentration times volume. Just to remind you, that's the equation that you're going to be using. So you've identified its titration question. Now highlight the question about what chemicals and what values you got for each chemical. So talking about the concentration of some sulfuric acid, and we're titrating it with sodium hydroxide. So let's look at the hydroxide first. And the question tells us we've got 25 centimeters cubed of 0.0880 mole per decimeter cubed sodium hydroxide. So if I were you, I would highlight all of those values relating to sodium hydroxide in one colour. So all my sodium hydroxide is now in yellow. When I come to check my work later, I can look at, have I identified everything to do with sodium hydroxide in yellow? Yes, I have. It just speeds up the checking at the end of the exam. Then choose a different colour for the other chemical, which is sulfuric acid. I'll highlight all of that in blue. So then have a think about what's actually going on physically. So if we did this as an experiment, what's going on? So 25 centimeters cubed of this sodium hydroxide. Well, we always measure 25 centimeters cubed and put it in a conical flask. So let's draw a quick conical flask, label it with sodium hydroxide. We've got volume equals 25 centimeters cubed and concentration 0.088 mole per decimeter cubed. And then it's neutralized by this amount of sulfuric acid. As soon as you get a weird value like that, easiest way of measuring that, or most accurate way of measuring that, is going to be in a burette. So that's going to be your sulfuric acid. And we know the volume of that is 17.6 centimeters cubed. Now, in my little diagram, which is just to help me, I don't care about significant figures. I don't care about the units, don't really care about significant figures. I'm just going to write down the values there to work out what I'm going to calculate. So to use this equation at the top, number of moles is concentration times volume, I need to know the concentration and volume of something. The only chemical I know the concentration and the volume of is the sodium hydroxide down in my conical flask. So number of moles of sodium hydroxide, always good to label everything in your calculation. It's going to be the concentration. And the examiner knows that I know that's the concentration because I've written it down on my diagram, multiplied by the volume. But because volume has to be in decimeters cubed, I need to divide it by 1,000. And that will give me 2.2 times 10 to the minus 3 moles of sodium hydroxide. So once I know how many moles are in my conical flask, I can just work out how much sulfuric acid there is because I've got a balanced chemical equation. This is where the reacting moles comes in. If you know the moles of something, you can use the ratio to work out the moles of anything else in your question. So the ratio of sodium hydroxide, which is what I know the moles of, to the sulfuric acid, which is what I don't know the moles of, is going to be 2 to 1, because 2 moles of sodium hydroxide neutralizes 1 mole of sulfuric acid. It's the big numbers you're looking for in the question, the coefficients. So the moles of my sulfuric acid, because it's a 2 to 1 ratio, to go from 2 to 1, I need to divide by 2. So to work out the moles, I need to divide the moles of sodium hydroxide by 2. So I have 1.1 times 10 to the minus 3 moles of sulfuric acid. Now the question wants to know the concentration of the sulfuric acid. So if I go back to my diagram, I can actually write in that now I know how many moles there are of what's in my burette. And now I know two things about that. I can go back to this equation, number of moles equal concentration times volume, rearrange it. So the concentration of my sulfuric acid is number of moles divided by volume. My number of moles, 1.1 times 10 to the minus 3, I've just worked it out. And I want to divide it by 17.6, but concentration is in moles per decimeter cubed, so I need to get my volume into decimeters cubed as well, so divide that by 1,000, and you end up 0.06250 moles per decimeter cubed. So I've given my answer to 4 significant figures, mainly because all the other data in the question has also been given to 4 significant figures. And that's a relatively straightforward titration calculation. Work out the moles of something that you know the volume and concentration of, do the ratio to work out the moles of the other thing, and then do whatever the calculation is at the end. Normally, in this case, it'd be work out the concentration.